Good morning, everyone. Hope everyone's doing well. We are getting started here for October's Swoon at the Moon. Joining us here today is people on their way to their works in the morning commute. And you might be wondering, why on earth are we doing this in the morning? Well, let's go ahead and jump right in. Again, welcome everyone. My name is Eric McLaughlin. I'm the astronomer for the Rancho, Mirage Library and Observatory, being helped out today by Lauren Zuckerberg, our observatory coordinator. She's there in the chat. I will try to keep an eye on chat as we're going. I will note, since we're actually doing this during the day, it's a little weird, I know, doing astronomy events during the day, but there is a little bit of reflection on the screen, so I might miss some things there. So welcome everyone and good morning. What I have for us on the screen right now is our satellite view. It's a little bit behind, as you can tell. That doesn't show that sunrise has made it here quite yet, but this is a geostationary view from NASA's Worldview site. It's really handy, and while it's great to be able to actually see things for the afternoon and evening, and I can show you yesterday, can't really show you the sky with this particular camera view, though there are others that could pull out some more detail. But I'm not really focused on looking down. We want to be looking up. So this is a nice simulated view of our sky in Stellarium. We can see a few things here, and again, the sun is rising, and while Venus is up in our morning sky, it's already too bright to be spotting it. Plus, while this view here shows no clouds, the actual view has quite a few scattered clouds. So as we're viewing right now, keep that in mind when we're looking over at the moon especially. There might be times where things get a little hazy if one of those high clouds happens to pass in front of the moon. Now, that said, we also want to dedicate a little bit of time when we're done here to going over some things you might be able to observe after we're done here throughout the rest of the next month. There's a lot to see, and so we'll swing back around there as we're wrapping things up. All right. Okay, so again, this is our simulated view of the morning sky. You can see the twilight nicely simulated. Well, it's not exactly twilight at this point. The sun actually is up. I can see it on the projecting onto the building there when I'm looking this way. But the moon is in our western sky, which is really helpful for us right now, because if it was in the eastern sky, well, we'd be having trouble keeping the observatory open because we don't want to have the dome open and pointing towards the sun. And so we're going to do this right at sunrise, but if the sun gets much higher, we'll have to shut it down. So this might be a little bit short with regards to the main telescope view, so we will get there quickly. But again, why are we doing this in the morning? Well, it's worth understanding the perspective of things. So we're going to jump straight over to SpaceEngine here to help us understand that. And now you might be wondering, why are we looking at Africa? Well, when we're looking at this particular view, if you look directly above Africa there, you'll actually see the moon hanging out right up here. This object, that was not the shape I wanted to make. Anyway, let's see. I believe I want this one. Too many options. But yeah, so that object you see right up above there, that is in fact the moon. And one of the fun things about looking at the moon from this perspective is you'll note that the Earth and the moon have the same phase in this view. You have a mostly filled Earth, and if we were to keep the moon locked in our field of view, we would actually and this position over the Earth, we would pivot to the right, and the phase of the Earth would be also a waning gibbous from this angle. So what does that mean? Well, it means that if you want to spot the moon right now, you need to be on the opposite side of the planet from Africa, as shown here, which is where we happen to be. So again, if we're locked on here, let's see, I need to be locked on the Earth. We can swing on around and see where we actually are over here, right near sunrise. And so that is why we are here in the morning, because if you want to see a waning gibbous phase of the moon, you need to actually see it. Well, you can spot it in the late evenings. We didn't want to keep you up way past midnight, so we decided to start early today. All right, so with that said, I will jump back to these slides and give you another perspective to further show why that is, and that is our moon phase map here. And this view gives us a lot of good information, but we get a lot of even more good information by pulling up this local view, the view right up in the upper left hand corner there. This isn't to scale, but it is to orientation, and again, with this orientation you can easily see why, if we're actually looking at this, we need to be over in morning over here. The morning is there because the Earth rotates this way. So if the Earth's rotating that way, yeah, if you want to catch a good view of the moon in a waning gibbous phase high in the sky, you need to be there during the morning. Now, this view also shows the actual eccentricity of the moon's orbit. It is not a perfectly circular orbit. You can actually see down on this side is where perigee is, and apogee is over here. So the moon is actually quite a long ways out in its orbit. And again, we can actually also see that back in this view. Looking behind the moon, you can see a nice diagram showing the Earth to scale and to distance along this line all the way out to here, where you can see the moon is very near apogee, its furthest distance from the sun there. Yep. Yeah, and we got some comments regarding geosynchronous satellites, because that's what we were using a bit earlier. That geosynchronous satellite means it is always over that spot on the Earth. But yeah, okay, so we've looked at a number of things here. I want to make sure we get good views of the moon before the sky gets even more blue. So let's jump straight to our small telescope view right now. There we are. So here we are looking right at the moon with a good context view of the moon. And let me adjust it, pull things back in a bit here. And what we can see now is a good portion of the Earth-facing side of the moon. What you can see quite readily are the mare, the seas of the moon. And when we're looking at those seas, of course, the most famous one is the one right over here. This is, of course, the Sea of Tranquility, where the Apollo 11 landings happened. They happened right down here. And while that is the most famous portion, there are other really cool things to spot. This whole big area all over here is the Ocean of Storms. It is of course, has a fancy Latin name that I'm sure I will mispronounce if I just jump to it. Again, we actually had it back over here in this view, better seen in this view here, if I can actually get it to cooperate. There we go. Yeah, Oceanus Procellarium. Yeah, this whole area, we have Mare Imbrium, Mare Insulum, and you'll also note the Apollo 12 and 14 landing sites there near the southern edge of that area. Now, the other thing you'll note in this view are those two big craters there. We'll take a closer look at them in the big telescope, but they are nice and prominent in the small telescope view as well. Those two craters right there and there. So, without any further ado, I want to get to the big telescope view, and let me actually make sure it is right where I want it before we switch to it. Let's see, get back up there. Yeah, I want to show off those craters because those are looking really nice. Which craters are those? Well, I want to show you this area down here where we have a few things. We got Theophilus hanging out with a nice central peak, as well as a few different things along the edge there, right on the edge of Mare Nectaris, excuse me. All right, so with that said, to the big telescope. There we are. So you can see Theophilus right there, that really wonderful crater right here that has that very pronounced central peak. that is what happens when you have craters that are large enough, or rather are formed by large enough impactors. When they hit the surface of the moon, or any body for that matter, they will not only dig out a big crater, but it will actually rebound and make a nice peak that can actually freeze out and make a nice mountain right in the center of the crater, like this one. Now again, that one is Theophilus, which I want to get, make sure I give you the correct information on. There it is. And, yep, so Theophilus is around 110 kilometers across, or 68.4 miles across. So that is what you're looking at there, something that would cover a significant chunk of Southern California, really. Really would cover well beyond the scope of this valley here. It is a dramatic impact site there. Also visible right across the way there. That little crater right there is, oh boy, Madler. That's an A with an umlaut on it. It's around 27 kilometers across, or about 17 miles across. And we got a nice set of other things. Let's see if we can actually spot it. I want to see Sinus aspiratus. It's a very small little bay or plain, as they said. As they would say, it's that region over in this area right up over here. Let's see. Welcome from Minnesota. All right. Let's see. And right near this area, actually right towards the top edge of the screen, right about over here is where Surveyor 5 landed, and Ranger 8 not far to the right of it. But yeah, this area also is not far from a couple of other important landing sites, including Apollo 16. Apollo 16, let's see if we can actually navigate our way over near where they landed. Let's see, we want to nudge the scope up this way. Come on. Gotta make sure this controller actually is connecting. There we go. Now the blue hue you're seeing is not the moon, it's our sky, by the way. I'll adjust the exposure, try and take that down just a bit. Okay, now we're looking where we want to be. Okay. That going there. Let's see if I can't actually spot the Apollo 16 landing site very well. Bit of a challenge because there's a lot of stuff going on over there. Let's see. So we can spot Kant crater, which is this one right here. And Kant is around 33 kilometers across, or 20 miles. So that is roughly the scale of the Coachella Valley. Yeah, around 33 kilometers. Like, not the whole length of it, but rough measurement-wise, yeah, if you want to measure the Coachella Valley, you need something that's around that 30-kilometer mark. And so, yeah, that crater there is roughly your size comparison for that. And not far from there, I'm looking well enough. Let's see. I'm looking for something specific. That's there. Question is, can I spot Doland? Great, glad you've been enjoying using some binoculars there, Steve. Those are always good to have for no other reason than to see more than you would expect to see, even with just your eyes. Getting those large aperture lenses are great for seeing a lot more. Thank you for joining us. Have a good day at work, Steve. All right. Let's see. Almost got us nailed down where we want to be, where I'm trying to find Apollo 16. I want to give a nice, accurate marker here. Let's see. We're not far from Kant. Want to say, is that Lindsay? Oh boy, hard to spot some of these. Yeah, want to say right up in this region up here. But yeah, there's a few craters that are a little bit hard to spot because of the map I'm using has a little bit different features going on, and also we can go back and compare with this view here, Apollo 16. Yeah, you can see Kant labeled right there as well. Yeah, Kant would be this one here. And so we're trying to spot Apollo 16's landing site right up over here. Should be able to spot these two craters pretty nicely to help give us a nice way to triangulate that. Let's go ahead and see if we can't pull that off. Get back over to the big telescope view. We had Kant right over here, and those two craters should have been these two here. So then Apollo 16 landing site should be, yeah, right about this area. Okay. Haven't had as much luck spotting Apollo 16 in the past because it's in a much more busy terrain than Apollo 11. So, yeah, right about there is where Apollo 16 is. And there's a few other craters I really want to highlight. I pointed out Copernicus and Kepler earlier, but let's actually go see if we can't find them over in the Ocean of Storms. On up this way here. Still might need to adjust that exposure. Dealing with more daylight. Speaking of exposure need adjustment, my camera needs a little adjustment. We'll notch that exposure down one. Might be a little dark now, but okay. All right. So back over here. Where are we going? Should be near some seas. Oh goodness, it is too bright. Let's just bring that all the way down there. All right. A little bit better. Okay, that's where I think we want to be going. That's probably Copernicus there. Either that or Kepler. Need some more references to help me out. Yeah, I'm pretty sure that's Copernicus. Got a little bit of a cloud moving past the moon right now too, so that'll also be why it's slightly blurry. But yeah, where are we trying to go again? Just to give you a nice comparison view, we'll pull this over. We're trying to wander all the way up here, and those two bright craters there are respectively Copernicus here and Kepler here, named for two Renaissance astronomers. Copernicus was the first to propose a serious heliocentric view of the universe, that is really putting the sun at the center of the solar system, and Kepler provided much of the mathematical and observational evidence for that model many years later. Kepler was around the same time as Galileo, and so Galileo also put forth a lot of the philosophical arguments as to why the sun could be at the center of the solar system. But yeah, so those three were instrumental for our understanding of a lot, and there's a good reason why you find things named after them. So these are what we're looking for, and I'm pretty sure we were looking at Copernicus. So let's get back over to that big telescope view. Yeah, we're looking at Copernicus. Our view is slightly rotated. I know we're looking at Copernicus because of this crater down here and this ridge going out there. That is... let's find out what crater that is. I can only remember so many names of craters on the moon, so got to look up a few. Let's see. Oh, that's Eratosthenes crater. Very nice. It is 58 kilometers across, or 36 miles across. Eratosthenes was a librarian at the Library of Alexandria. He paid someone to walk hundreds of miles down into the African desert, in the Sahara, that is, going down south to find a specific well and count his footsteps going both ways to measure the distance to that well. Using that along with a few measurements of shadows, he was actually able to get a very good estimate for the circumference of the Earth. He was really crucial in our understanding of knowing that the Earth is round. So Eratosthenes, that crater right near the center of our field of view there, and then Copernicus in the upper left, with Copernicus having a diameter of 93 kilometers, or 57.8 miles across. I do want to go find Kepler as well, which should be up and to the left of Kepler in this orientation. Or sorry, Copernicus. There's Kepler right there. Kepler is noticeably a smaller crater there. It is actually on the order of around 31 kilometers, or 19.3 miles across. So that is where we're looking right there. Let's see. What are those radial lines near the craters? That is an excellent question. When you have impactors hitting the moon, they often dig up material underneath, and that material tends to be brighter than the surrounding material. A lot of material sitting up on the moon, it is actually quite dark in color. We like to think that the moon is a nice bright gray. It's actually a very dark gray. There's just that much sunlight falling on it. So it's very easy for it to for stuff to contrast against that. And when those impactors hit there, it dug up material that was deeper and actually, by and large, lighter in color. And because it was lighter, or it was lighter in color because it hadn't been sitting out in the sun for so long and actually getting basically cooked. So having all that having been dug up from that impactor, it's quite a bit brighter around it. That is an excellent question. Eventually, over time, that material will likely darken, but that'll be a long time. Yep, and Ron points out, again, when I say they're cooked, yeah, there's a reason why they would smell like burnt gunpowder. Yeah, the temperatures on the surface of the moon get well into oven temperature range every day. So it gets quite hot up there on the sun-facing side. And when I say sun-facing side, I mean just like the daytime side. The moon rotates at the same rate at which it orbits the Earth. That's why we only see one side of it, which means a day on the moon takes one lunar month, around 28 days. So one full day, that is day and night cycle. So yeah, you got 14 to 15 days or so of sunlight falling on one particular spot, cooking that stuff for so long. Yeah. Let's see. Is there anywhere else we really want to visit over back at the moon right now? Let's hop back over here and take a nice look at our overall picture here. Let's see. Where would be a fun place to visit? Well, there's always a fun place to visit that I am going to be very unable to spot exactly because it's right on the edge of the Earth-facing side, but I like to try and just scope past it for personal reasons. Why would I scope past it for personal reasons? Well, because there is actually a McLaughlin crater, but that crater is not named for me nor anyone I know of being related to me. Nevertheless, it's cool to me that there is a McLaughlin crater. It is right on the northern edge of the Earth-facing side, so it'll be up in this area somewhere. Right along the edge there. And we do have a little bit of a blurring. Yeah, we got some more clouds moving by there, causing a little bit of disturbance in the atmosphere. But yeah, right up somewhere along this edge would be where that crater is. Anyway, there's not much detail to see there because it's actually further away from the terminator, that dividing line between the day side and the night side, which we can see down on this edge of the moon. And so we'll spend a little bit of time glancing past here to spot a few more things. Let's see. I want to know what that big crater is there. Let's see. I want to make sure I know where we're actually even looking right now. So let's hop back over here and pull this one back up. We are currently looking off up on this side here. And so we're right near Mare Frigoris, and we can see Gartner crater as well as Democritus crater up there. So let's see. The far side of the moon is actually more heavily cratered than the near side. The mare we see here on the Earth-facing side is actually areas where the crust was a little bit thinner, and thus, at some point, lava filled it in much after the highlands were formed. And so that's one of the reasons it appears darker. It's actually straight up lava-filled sections of the moon, and it's also substantially younger. Therefore, there's been less time for it to be heavily cratered. So the Earth-facing side does look quite different than the not Earth, the far side of the moon. But yeah, excellent question there. Let's see. Am I looking where I think I am? Yeah. There's those three, which means those two craters I'm looking at are... Okay. We can hop back over here and identify those two big craters in the lower left. The closer one is Eudoxus. That's Eudoxus. And it's about 67 kilometers across, or 41 miles across, whereas the one above it is... It's named after Aristotle, but it's Aristoteles crater at 87 kilometers across, or 51 miles across. And we can actually, if we nudge the camera back over to... Oh gosh, yeah, we're right in the middle of a cloud now, so we'll let that pass while we're looking here. But yeah, if we nudge this back over this way, should be able to spot... Let's see, is that where we are? I want to spot Plato. Oh, it's not that one. Going the wrong way. There it is. Right there at the top of the screen there. That is Plato, named for the philosopher, of course. That one is 109 kilometers across, or 67.7 miles across. So it's a good size one there. Notably, though, you'll note how it has a very dark floor. It is right next to one of those mare, which means it may have actually filled in. It may have been an old crater that actually filled in. Good question, though. Let's see. Good question that I don't know all the answers to. Oops. Let's go back down. All right. I want to spot more of the Terminator. So we are bordering Mare Imbrium. And let's see. There's other interesting details to note on Mare Imbrium. Actually, yeah, if we nudge ourselves up this way. There it goes. Got a nice sinus iridum is that big bay-shaped thing you see there. Sinus is a name for bay-like shapes on the moon, so that is sinus iridum. But right near sinus iridum is where Luna 17 and Lukhod 1 landed. Some Russian probes there, right up in this area. Oh yeah, fun things to note on that. Let's see. But yeah, we are at Mare Imbrium. Let's see if there's anywhere else we want to note here. Oh yeah, well, as we head on south, we'll pass where Apollo 15 landed. So we'll head back to the southeast on the other side of Mare Imbrium. Over to the right, please. There we go. Let's see. Make sure I get my bearings right. Do. Go too far? Where am I? Very easy to get lost in all these craters. Checking on that. Okay. Okay. There's Plato again. Right up there. Okay. That's where I am. I'm too far that way. That's what I'm looking at. Okay. Those two craters right near center. Nope. Down, please. Down. Those two craters are Aristilius, the one to the top, or to the right, rather, is around 55 kilometers across, or 34 miles, and the one below it is Autolycus, which is around 39 kilometers, or 24 miles across. And that big sort of flattish crater here, that one is Archimedes. Now, we are quite close to where where the Apollo 15 landing was. It was actually right near the bottom of the screen there. So let's see if I can't actually pull that up towards center of the screen. I really would love to see something that I'm sure we aren't going to spot well. And the thing I would love to see is actually the canyon that they were exploring there. Canyon actually being a there, it would have been what's the name of it specifically? It is, I want the specific name of it. Rima Hadley. Yeah. But I don't think we can really spot it all that well looking at it, our current conditions right now. But I want to be able to get some more context. Where is that one? Looking at those, they almost line up straight with it. So yeah, our Apollo 15 landing site would therefore be right about this region here, with the actual landing site being probably about right there. Yeah, so that's about where the first lunar rover was used with Apollo 15. Yeah, there were a number of landings on the moon. There were only 3 that actually used a lunar rover: 15, 16, and 17. All right, let's see. Let's jump on down this way here, because I do want to skirt across that that Terminator one more time. All right. I think we're about ready to wrap up things here with the moon. Yeah, we're back down at Theophilus here. Still a wonderful crater to swing on by. And let's actually pop over to our small telescope view, which has no doubt wandered a little bit. Yep, there it is. So yeah, you can still see we have quite a good view of the moon, despite the fact that it is straight up daytime. So there are a few things I want to go over, but before we jump into that, I'm going to go ahead and start closing up the observatory. So you'll be able to see just below me there the view of the main dome. So I'll go ahead and start closing everything down in there, and we'll keep this view of the moon on the small telescope out here because, well, we don't have as much to deal with on that front. So let's see, I need the control computer interface. The first thing we need to do with that is actually close up the telescope. And to give you a good view of that, I'm going to swap the camera over to this one. And you can see right at the bottom of that view there, the opening on the telescope. And so when I go over here and hit this button, you'll see those little petals close over it. There it goes. Those are the dust covers that cover the main mirror on the telescope. They're very useful for keeping it clean. It's a pain to clean a telescope. It has to happen eventually, and so we try to prolong the time between cleanings as long as possible. All right, so there it is, all closed up on that, and that means we're ready to actually start closing the dome. So we'll switch, actually, no, yeah, we'll switch. We want to see the way it closes is there are two sections to the dome. When it's closed, it will they will meet up. The first thing that happens when opening is the upper shutter slides over the top, and then the lower shutter pops out. So in order to close it, you need to do the reverse. Close the lower shutter, and then bring the upper shutter down. So let's go ahead and get that happening. Let's see. This button here, and this button, well, we want to switch the view first. Hold on, don't want you guys to miss anything. There we go. All right, so now we'll go ahead and close that dome. And so it takes about 3 minutes for everything to close down. So while that's happening, I'm going to go ahead and start talking about other things you'll be able to see over the next month, because the moon looks great, but there are other great things to see. We are actually today at the closest approach of Mars to the Earth for about a 2-year period. Opposition is coming up on the 13th, and that is when the Sun and Mars will be on opposite sides of the sky. But right now, we've got, because of the eccentricity of orbits, we're actually closer to Mars now than we will be next Tuesday. So next week, yeah. So it is not crazy, right? I'm not counting wrong. Tuesday, right? Yeah. But yeah, so so you'll definitely want to be looking at Mars if you've got any kind of magnification. We're not going to be doing a live stream of the opposition of Mars, but we are going to be getting some images, and we'll be publishing those. We'll also be publishing our next episode of Distancing with the Stars coming up, which will be about Mars. So we'll be going into some detail on things going on at the surface of Mars. Let's see, you can see the lower shutter is now just about completely closed. And so if we switch our view back to the other side, there's the upper shutter closing. Right beneath me, it's just about all the way down there. Yeah, or all the way out of that field of view there. So let's see, can I nudge that? I want to see if I can nudge that down a bit. Can I nudge it down fast enough? No, it's already too late. All right. So let me switch that back to the other view so you can see the rest of that closing. There we are. So yeah, eventually you'll see towards the top of the screen there. Oh, it's already, yeah, I do need to nudge it down anyway, so you can actually see the top of that finished closing. Just drag, there it goes. There's the top of it. Okay, now you can see the top of that going down. All right. Yeah. Yeah, hope to see you too soon, Ron. Yeah, it'll be great to see everyone again. Really looking forward to it. But yeah, so other things we can actually look at. Let's see, we're on the big telescope view. Sorry. There, back to small telescope is that. But actually, let's hop over to our information slides and back to Stellarium, because again, talking a bit about Mars. Where can you expect to find Mars? Well, if the Sun and the Moon are on Sun and Mars are on opposite sides of the sky, where should you be looking? Well, that means at somewhere near true midnight, when the Sun is at its lowest point below the horizon, Mars should be at the highest point. True midnight is not far from normal midnight, though daylight saving time likes to ruin that. So what we can do is actually just advance time here into the evening hours. And as the sun goes down, you can see Jupiter and Saturn are hanging out to the south right after sunset now. Still great to view. And over the next month, again, those two planets will get closer and closer, heading towards their conjunction on the winter solstice, December 21st. But yeah, so at this point, you don't see much with Mars because, again, it will be at its highest point in the sky near midnight. So you'll want to wait a couple hours, and by 9 p.m. or by 9:40, as it's shown here, Mars will be very high in the sky. It is getting nice and bright, so it'll be easy to spot. And it will also stay up in your sky for a good long while. And you can actually see, I would have loved to actually have pointed out Mars this morning. I was able to spot it as I was setting up, but by the time we started, it was already too low and already too bright out. So it is going to be easy to spot in that early evening hours and through the night. As you can see near or shortly after midnight, it is very high in the sky. We can pull up a nice grid to show the point at the top of the screen there is zenith, straight up, and so it gets nice and high in the sky. All the planets lie near the ecliptic, which is this line here. That is the plane of the Earth's orbit projected onto our sky, thus making a nice line. And so the plane of the Earth's orbit is very close to the plane of all the planets in the solar system, and so all the planets will be near that line in the sky. And again, this green line here is the meridian, the line connecting due south to due north, and as you can see, near midnight, it will be very near that line, and it will get closer to it as we go on, or closer to that line near midnight as the days go on. See, we can advance through the days, and we actually go right near midnight. There we go. We can actually see on opposition, it is going to be, opposition was back here. It's going to be a little bit ahead of it, but that's going to be due to differences between daylight saving time and the difference between the solar clock and the clock on the wall, the equation of time as it's referred to. It's the something that comes from a few different factors, including the eccentricity of the Earth's orbit and the incline of the angle of the Earth's rotation axis with its orbit. So that's definitely something you'll want to be watching in the coming months, or over the course of the next month, rather. You definitely want to be spotting Mars. If you're someone who's up really late at night, you can actually spot Orion right now. It'll be a while before Orion's really an evening thing to observe, but if you're morning observer, you can spot it really well at this point. And also by 6, Venus is up and nice and bright in the night sky. Again, just before sunrise, you can spot Venus really well. So back to our evening skies. What else can we spot? That's a bit too far back. Well, there's a lot of things. Jupiter and Saturn are still near Sagittarius, and if we want to view that, we can highlight these constellations here. Sagittarius, as you can see, is right down there. It's where the center of the Milky Way galaxy is, but at this point, it's going to be hard to spot the Milky Way galaxy's center due to, or the actual galaxy, the glow of the band across our sky in that area, just because it's near the horizon, still near sunset. So, but the other things we can spot, of course, are the summer triangle. Surprisingly, is, even though we are well into fall now, is still nice and high in the sky right after sunset. It consists of those 3 stars there. We've got Deneb, Altair, and Vega there. That is a ugly triangle, but that is the summer triangle right there. And there's a lot of fun stuff to spot up there. If you've got a telescope, it's always a good idea to go and take a look at M57, the Ring Nebula. It's a good challenge too, because you need a good amount of magnification to spot it, and it is small. It is right between these 2 stars at the end of the parallelogram of Lyra, and if we zoom on in, I should be able to spot it. There it is. That guy right there is the Ring Nebula. If you do go looking for it, as I like to always note, it is not going to look this colorful through the eyepiece. The thing about our eyes is our eyes will spot light before it spots color, and so dim objects tend to not have color when we look at them. So don't expect to see color if you get a telescope on this object. It's a wonderful challenge. I highly recommend trying it. It's a good thing to just test your capabilities, especially if you're not just sending a telescope there, but rather guiding it yourself. Using these two stars as your signpost really helps you find it. Yeah. Let's see. Okay. Good morning, John. All right. So I just wanted to do a quick view of a number of things there. Again, as we go on through the course of the next month, our evening skies will shift slightly because we are orbiting around the sun, and so our view shifts over that time. So as we make our way on into November, we'll see everything shift on as well. And so by mid-November, Mars will be nice and high in the sky in the early evening. Jupiter and Saturn will still be nice and visible. Now, I'm going to back up through that again. Again, we did this in the morning because we wanted to watch a good view of a waning gibbous moon. And you can actually see here how the moon shifts in the sky. It shifts each night. It shifts quite noticeably. So it's always interesting to not just look at the phases of the moon, but where the moon is with respect to the things behind it. And as this time frame in October, late October, it's going to be passing near Jupiter and Saturn, and then over near Mars. Those will be some good signposts for you to be able to actually spot how much it's shifting through the sky, because the moon will outshine just about all those stars in that area. So it's always a great thing to note there. But I think that will cover our little bit of a stargazing primer right now. But before we wrap everything up, do you guys have any questions about what we've been looking at here today? We'll pull up the moon in our small telescope one last time here. I'm going to switch off some things in the observatory that don't need to be on now that we are going here. All right, we will switch off the exhaust system, which makes sure the inside air in the dome is equalized in temperature with the outside air. Since I closed the dome, it doesn't need to be on, so I want to make sure I get that off now. All right, doesn't look like we have any questions, so at this point I want to say thank you everyone for being here, and a special thank you to the Rancho Mirage Library and Observatory Foundation. Without them, we would not be able to have events like these. So again, a special thank you to the Rancho Mirage Library and Observatory Foundation. Also, thank you to Lauren Zuckerberg for helping me out with the chat here. I know it's been actually bit difficult with the reflection for me to spot everything, so thank you again there. And thank you to all our docents, a number of which have been here as well. Really appreciate all your comments and feedback as well. So with that, thank you, and make sure you guys, as you're going about your day and night, keep on looking up. Have a great day, everyone.